Okay, hello everyone, I'm Mišof and I'm going to present problem B, better productivity. In this problem we have a factory with P assembly lines and N workers. Each worker is an interval in time. We have information when he arrives at work, when he leaves work. And we have to assign all of these workers to the assembly lines in some way. Now the assembly line can only be operational when all of its workers are present. So if we have 4 workers like the black intervals here, this particular assembly line will only be active during this red interval. So the maximum of beginning of the times when they arrive until the minimum of the times when they leave. We have to assign at least 1 worker to each assembly line, and we want to maximize the sum of times when any assembly line is in production. Okay, so the solution for this problem consists of 3 steps. The first one is probably the hardest one. The first one is we need to make the following observation. Whenever we have 2 workers, such that one of them has an interval that covers completely the other interval, we will call the bottom the better worker. We will say that this is a good worker. Now the intention behind this observation is that we don't actually care too much about these good workers, because whenever we assign a bad worker to an assembly line, we definitely can assign any such good workers to the same assembly line without influencing the interval. So the bad workers are the ones that actually cause the most troubles. So in the first phase, we just use 2 cycles over the area of workers. We identify all of the good workers, the ones that cover somebody previously mentioned, and this leaves us with just the bad workers. Now we are going to step 2. If we take a look at the bad workers only, so none of them covers none of the others, they have to be if we sort them according to the time when they arrive, they have also to be sorted according to the time when they leave. Because if you take a look at any of them, if I arrived later than this one, I cannot leave sooner, because then he would be a good worker. So we have this sorted order that looks like this. And now whenever we pick that this worker and this worker go to the same assembly line, then we can freely add all of the workers in between without losing anything. So this leads us to a pretty simple dynamic programming. So for each prefix of this list of workers and each number of assembly lines, we will compute the optimal solution. And now we are going to the general solution. So this is step 3. And it is easily shown that the general solution will have the following form. Some of the assembly lines will actually be covered by these bad workers, but some of the lines, for better productivity, we can also cover by good workers only. And instead of putting multiple good workers onto such an assembly line, it is clearly optimal to use just 1 good worker per each assembly line, and to start from the ones that are in the work for the longest, so from the longest interval. So we take all of the good workers we removed in step 1, we sort the intervals according to the length, and now we try all possibilities. So we try all possibilities for the number of lines that each get one of the good workers, and then the rest of the lines is covered by the bad workers using the dynamic programming. And the optimum of those is the optimal solution.